everyone. We're discussing Coulomb's law. And so far we have seen that if we have been given 2 point charges Q1 and Q2, separated by a distance of r, then for same polarity, this force is F2, this force is F1, then F1 upon F2, first of all is 1. One is action, other one is reaction. And this magnitude is K times Q1, Q2 upon R square. What is K? We have discussed it in the last class, and in detail I told you when we will discuss about K. So, this is something which we did in the last class, that this action and reaction force, its magnitude is K times Q1, Q2 upon R square, provided both Q1 and Q2 are point charges. This is something which we have done. Now, the first thing we can ask you is, we can see that F1 equals to F2. So, they will ask you things like this. A very short answer type question. Option A, option B, option C, and finally option D. This is the question. What is the relationship between F1 and F2? Action and reaction forces. Write down your answer in the comment box. If you think that option A is correct, then write down A. If you think that option B is correct, then write down B. Note down the question and write down the correct answer in the comment box. Look, without arrow, it means magnitude. First option says that magnitude of action and reaction forces, that is same, which is correct. Whatever be the combination of charges Q1 and Q2, you will always have equal and opposite magnitudes. If we do not use arrows like this, we are only discussing magnitude, and therefore this first option is correct. And immediately second option becomes wrong, because it says that if F1 represents magnitude, then this second option basically is something like this. 10 equals to minus of 10. First option is 10 equals to 10. Now you can see that this is correct and this is wrong. Now, when you look at the third option, you are equating vector terms. And whenever we equate vector terms, we need to take care of magnitude as well as direction. When you say F1 is equal to F2, it means both action and reaction have same magnitude. At the same time, they have same direction also. But you can see that they have same magnitude, but their directions are opposite. Which means this third option is not correct. What about fourth option? Fourth option says both vectors are of equal magnitude, but direction of F1 is opposite to that of F2. How do you read this thing? Direction of F1 is opposite to that of F2, and they have same magnitude, which means this option D is also correct. The correct answer is A and D. Put on this. And in terms of vectors, if you want to understand, look at this F1. This is the direction. What is this direction? You can say 10 minus I cap. What is this? Minus I cap. What is F2? F2 is this. What is this direction? I cap. 10 I cap. Now, what do you think? Is it correct? Minus 10 I cap is equal to 10 I cap. No. LHS is not equal to RHS, and therefore this option is what? Wrong. Look at D option. What is F1? F1 is minus of 10 I cap. Negative sign is showing the direction, left. What is F2? F2 is 10 of I cap. What is F2? 10 of I cap. And then you need to put additional negative sign. Both LHS and RHS are what? Same. A very elementary but important question. First of all, remember, whatever be the combination of Q1 and Q2, you will always have same magnitude. But directions are opposite, and therefore that's how you should present your answer. Do one thing, also note down these things. It will help you in remembering the way we answered the question. We have taken magnitude 10, and along the x-axis we have taken I cap and minus I cap. Write down like this also, along with each and every option. Write down vector form of Coulomb's law. Vector form of Coulomb's law. And we did the same thing with Newton's law for gravitation. We developed vector form. Exactly on the same line, we will discuss Coulomb's law. Look here. This is Q1. This is Q2. Right now we'll take them positive. Both are positive charges. And ultimately, when we develop the final format, it will not depend on the polarity of Q1 and Q2. It will be valid for everything. But initially, we'll take Q1 and Q2 both as positive charges. Q1 and Q2 are positive. Q1 is at position A. Q2 is at position B. Separation between Q1 and Q2 is R. Now I need force on Q2. Force on Q2 by Q1. And I need to write vector form of this force. What I need is force on charge Q2 coming from charge Q1. Whenever you write vector form, you have magnitude and you also have direction. What is the magnitude? Magnitude is K times Q1 Q2 upon R square. That's the magnitude. K times Q1 Q2 upon R square. Regarding direction, I had asked you the same type of thing when we discussed gravitational masses. So the question I'm asking you is, for direction part, what should I write? A to B or B to A? What do you think is the correct direction? A to B or B to A? Go down this much and write down the answer in the comment box. What should be the correct direction of force? Should it be A to B or B to A? And remember, we need force on Q2 coming from Q1. Look, only few have answered the direction part, and let's see if the answer given is correct or not. Let me draw the setup over here again. We have Q1, we have Q2. The way you find direction is, first of all, remember both are positive charges. We need force on Q2 coming from Q1. It's a very easy thing, but I don't know why people commit these silly mistakes, and therefore I'm asking you this whole part in this form. Which direction representation is correct? First or second? Let's answer this thing step by step. Many a time people find it, I don't know why they find it difficult to represent the whole thing in direction form, and therefore let's understand the whole thing step by step. If Q1 and Q2 are given like this and both are positive charges, and then I ask you which direction of force on Q2, should it be like this 1 or should it be like this 2? What do you think is the correct answer? Write it down in the comment box. What do you think is the correct representation? Good. Now you're answering it in the right way. Positive charge always repels another positive charge. This is correct. This is wrong. Now once we have identified that this is the correct thing, Q1 is repelling Q2. Q1 is repelling Q2 like this. Now, forget about this. We have found the correct answer. This point is A, this point is B. This is A, this is B. Now, look here. I told you that we'll discuss the whole thing step by step. If you see an arrow like this, or you see an arrow like this, I hope you can see the arrowheads. Again, what is this? This direction is A to B. Look at the arrowhead. Look at this arrowhead. This arrow is pointing from B to A. This is A to B. This is B to A. Now, this force, which is the correct direction, this force which you see is the correct direction. Is it B to A or A to B? I'm asking such a simple question. So I'm giving you 20 seconds again. What do you think? What do you think is the correct direction? A to B or B to A? Now you know the direction of force. You just need to think that this arrow, is it parallel to this or this? What is the correct direction? Write it down in the comment box now. I've explained things step by step so that everyone can feel it. Do participate. Good. Now you can see that this arrow represents A to B. It does not represent this. Everybody will note down this whole analysis also. But so far we have found what? Q1 and Q2, they are both positive charges. This is Q1, this is Q2. You know that Q1 is going to repel Q2. This is force on Q2 by Q1. Force on Q2 coming from Q1 is this force of repulsion. What is this direction? A to B. It's a simple thing. A to B. Had it been a negative charge, then direction would have been B to A. But right now, this is what A to B. And therefore, this is correct, this is not. Go down this much first. Go down everything first. And this article which we are, this is the vector form of Coulomb's law. This is asked in board examination also. And basically it's good for board examination on the vector form. For competitive examinations, it's also good, but it's more important for board examination. Now, A to B. The way directions are represented, we do not write A to B or B to A. In vector form, directions are defined with the help of unit vectors. For directions, we take help of unit vectors. So, this A to B, instead of writing A to B, you must write AB cap. This is called unit vector. AB cap. This 2, you can say, simply becomes what? Cap. K Q1 Q2 upon R square AB cap. Your answer is complete, but we can further refine the answer in this form. AB cap. How do you find AB cap? How do you find a unit vector? You take a vector AB and then you divide this vector with its own magnitude. A vector divided by its own magnitude You can also write like this, or simply this. Either write down AB vector between two vertical lines representing magnitude, or simply remove the arrow. Vector divided by its own magnitude becomes a unit vector. Now, this AB cap, therefore, is this K times Q1, Q2 upon, now before we proceed, look at this R. What is R? R means separation between AB. What is R? AB, this separation. That means I can simply say small r is AB. Small r is what? AB. From this AB. And therefore, this r can be written as AB square. AB square multiplied by AB cap. What is AB cap? What is AB cap? AB divided by AB. AB divided by AB. When I write only AB, this is magnitude. When I write only AB, remember this is what is magnitude. So format is coming K Q1 Q2 upon AB square AB, which becomes this. You can continue with this. I'm writing the whole thing over here. Your force is coming K times Q1 Q2. The same force is coming K times Q1 Q2. AB vector divided by AB square multiplied by AB is what? AB cube. AB cube. This is one way of writing Coulomb's law in vector form. This version is also correct. We have shown the magnitude. We have shown the direction with the help of unit vector. So this is the complete form. Now this complete form, either you write in terms of AB, or you will find that we prefer R because it's smaller term, and therefore this same part now also looks like this. Pay attention to what I am writing on the board. K Q1 Q2 divided by, what is AB? What is AB? R. R cube. What is AB? What is AB? R. R vector. This is in terms of magnitude and unit vector. This is in terms of AB. This is in terms of R. K Q1 Q2 upon R cube, R vector. If you understand this much, then write down yes in the comment box. If you do not understand it, then do not hesitate. Simply write down no in the comment box. But do give me your response. Go down this much and write down yes or no in the comment box. And also write down that this question is good for board examination. This vector form, you can expect 2 marks question. Writing Coulomb's law in terms of vectors. Now, look at these things. This AB cap part we can write this. You can insert the whole thing as a side note. K Q1 Q2 upon R square K Q1 Q2 upon R square AB cap. What is AB cap? R cap. This is also a valid version. Magnitude K Q1 Q2 upon R square and direction is what? R cap. What is R cap? This is R cap. This direction A to B. This direction is called R cap. For example, you know that this direction is called I cap. This direction is called J cap. Line joining A and B, AB, this direction is called R cap. So what we are saying, we have this much magnitude and its direction is R cap. This is in terms of AB, this is in terms of AB, these two in terms of R. We will take a few examples, and if you have any confusion, that confusion will be gone. Now, that's how you will answer this question for board examination. But if they ask this question in any competitive examination that you need to find force, then just don't remember things like R vector, R cap. We'll use simple logic, you'll see it. And with the help of that logic, we'll answer our question. The whole exercise basically was for board examination. That's how you should represent it. But if they ask the same thing in any competitive examination in this form, let's say they gave us Q1 as 10 coulombs, Q2 as minus of 8 coulombs, Q1 is 10, Q2, look, is minus. Position of Q1, let's make it the first 10 a very easy one. Let's say the whole thing lies along the x-axis. this direction, this horizontal line for us in the first part, let's keep it easy, is what x-axis, and separation between Q1 and Q2 is 4 meters. Separation between Q1 and Q2 is what? 4 meters. Now before I start solving this, answer this question and give me your answer in the comment box. I need force on -8 by +10. Find out force on -8 Coulomb charge coming from +10 Coulomb charge. Write down the magnitude and direction. Remember, for simplicity, I have given you this line as an x-axis. You've got 1 minute's time. Let's see how many of you can answer it. Force on Q2 coming from Q1 in vector form. How will you answer this question? We need force. Now, the thing we should remember, very fundamental thing, what is the magnitude? Magnitude is K times Q1 Q2 upon R square. Simply write down this. Nothing special. You don't have to worry about AB cap or things like these. Question is very easy. Just write down what magnitude. Everybody knows this format. From 10, you know that magnitude is K Q1 Q2 upon R square. Now, if I ask you direction, look at this. It's a positive charge, negative charge. We need force on the negative charge, which is coming from the positive charge. Let's not waste time, and everybody can see that positive charge is going to pull this negative charge towards itself. This is the direction of force. Now, if this is the direction of force, and I say that this is x-axis, this is I cap, this minus I cap. You will write down minus of I cap. Magnitude, direction. You don't have to worry about AB cap, R vector, nothing. It's very elementary thing. This is x-axis. Force on negative charge coming from positive is this. That's the direction minus of I cap. Now, what's the value of k? 9 into 10 to the power 9. What is the value of q1? 10. Now pay attention. What is this? I told you that this is the magnitude. Pay attention to what I am saying. What is this magnitude? What is this direction? If I say this is magnitude, then this is q1, q2 should be 8 divided by r4 square. You will not put negative sign here. You will not put negative sign here. Why? Because what is this? This is what magnitude. In magnitude, you do not have any plus or minus. Simply write down everything without any sign. That is with plus sign. That meaning of sign, what is the meaning of negative sign with minus 8? It means Q1 is pulling Q2 towards itself in this direction. What is this direction? We have already shown the direction, minus I cap, minus of I cap. That's the answer. This is coming 8, 16, 2, 10, 5, 9, 5, 45. 45 into 10 to the power 9 minus of I cap. 2, 10, 5, 5, 9, 45, 45 into 10 to the power 9 minus of I cap. Complete answer. Remember what I said, you will not use a negative sign because when you write force, first you write the magnitude, then you write direction. This is the direction. Put on this. Only one person could answer this question correctly. We'll practice with the help of this question. Since only one could answer correctly, put down this. We have a charge of minus 10 Coulomb. We have a charge of plus 100 coulombs. Separation between the charges is 1 meter, and this is present on the y-axis. This setup was on the x-axis. You can see this time I have placed charges on y-axis. What I need is force on plus 100 by minus 10. take help from this, what we did, and produce a correct answer for this question. Take your time, take help from this, and then write down your answer in the comment box. Force on 100 coming from minus 10 Coulomb. Both charges are placed on y-axis. Separation between the charges is what? 1 meter. Look here. We need force on plus 100 coming from minus 10. Now, simple question which you'll ask yourself, negative charge, a positive charge. What type of force exists between a negative and positive charge? Force of attraction. This is the arrow. We need force on 100 Coulomb, 100 Coulomb charge, and this is the direction of that force. I hope you can see the direction. Now, force. Any vector has two things. One is magnitude. What is the magnitude? K. Q1, Q2 divided by R square. You will not use any plus or minus sign with this. This whole part, it only is magnitude. Magnitude is always positive. Will not use minus 10. K times Q1 into Q2 divided by separation square. Regarding direction, what is this direction? This is up. What is up? Up is called J cap. Up is j cap. Down is minus j cap. What is this coming? This is coming 9 into 10 to the power 1, 2, 3. That is 10 to the power 12 j cap newtons. This is the force. Magnitude is 9 into 10 to the power 12 and direction is what? J cap. Almost everyone has answered correctly, which is a good thing. I hope you understand the whole part. Those who could not, put down this. I hope those who gave wrong answer, they understand what went wrong with the answer. Some of you are answering minus j cap, but look, had it been minus j cap, then force should point downwards. And therefore, use simple logic. Forget about this negative and all. Forget about the negative part as long as you are writing magnitude. This negative simply tells you that negative charge is attracting positive charge and direction of attraction force is this, towards the negative charge. Once you find out that this is the direction, what is this? J cap. And therefore remember, it's always important to represent forces in this form with the help of arrows. Once you have decided or plotted the arrow, you cannot commit any mistake with direction. Now, let's handle some questions on Coulomb's law in this form. Look here. We have a charge of 9 Coulomb plus 9. Another charge Q2 plus 4. Two charges Q1 and Q2 are given. Both are fixed. These two charges cannot move. Separation between the charges is 16 meters. 9, 4, separation between the charges is 16. Question is, where should write down the question, draw the figure. Draw the figure. Write down the question. positive charges, 9 Coulomb and 4 Coulomb, are placed with a separation of 16 meters between them. Find out position of a third charge. Find out position of a third charge with respect to Q1 so that net force on this charge is 0. So that net force on this charge is 0. What is the question? This is Q1, this is Q2. Let's say we have a third charge. Where should I place this charge? At this position, this position, this position, this position. You need to define the position with respect to Q1. Like it should be placed here, or it should be placed over here. It should be placed at this position. Where should you place it? So that net force on the third charge, net force means force coming from Q1 and Q2. Total force becomes what? 0. Take your time, should not take more than 1 minute. Let's see how many of you will answer it. You need to answer in terms of meters. Like at this much, 5 meters, 6 meters, 7 meters from Q1 at this position. That's how you will answer your question. Now, let's visualize this question first. Look, suppose you place your third charge over here. This is some charge Q. How do you analyze things? Pay attention to what we are doing. This is Q1, this is Q2. Let's say this is third charge. This Q1 and this Q, let's say this Q is also positive. 9 Coulomb repels this Q in this direction. This is the force of repulsion. Positive charge is repelling another positive charge. This positive charge also repels this Q, third charge. This is F1, this is F2. Force coming from Q1, let's call it F1. force coming from Q2, let's call it F2. Now, suppose there is a body and that body is under two forces like F1 and F2 in this form, then is it possible that net force on this body can be zero? A body is being pushed by two forces F1 and F2 like this. And my question to you is it possible that net force on this can be zero? What do you think? Yes or no? Write it down in the comment box. We'll handle the question step by step. Do you think that we can bring this body at rest? That is, can we have net force zero? Yes or no? Try to visualize this. Try to visualize as if you are being pushed by two forces. Now, well, correct. Everybody has answered correctly. How do you find if you have a body in laws of motion? In laws of motion in 11th, you have done things like these. If you have a body, a force is pointing in this direction, another force is pointing in this direction. F total, it cannot be zero. It will move. You have a body, one force is acting in this direction, other force is acting in this direction. Again, F total cannot be zero. These two forces, net force cannot be zero. When can you make total force zero? If you have a body and body is being pulled by equal and opposite forces. If magnitude of this is 5, then magnitude of this should also be 5, and they both should act in opposite direction, then only F total can be zero. Very simple fact. If you have a body and you push it in this direction, you push it with same force in the opposite, both forces will cancel each other, giving you total force zero. This, everybody knows. This is what you have a force along I cap, you have a force along J cap, body will move somewhere between I and J. Which means, never ever a situation like this can produce zero force. That means you cannot place your Q1 at some position in this form. Therefore, where should you place it? Now, look here. If I place my charge Q on the line joining Q1 and Q2, then what will happen? Line joining Q1 and Q2, and on this line I have placed my Q. Line joining. Let's show this in this form. Line joining Q1 and Q2, and on that line somewhere we have placed the charge Q. Now what will happen? This Q is going to repel Q in this direction. Force of repulsion. Q1 is repelling Q in this direction. Call it F1. Again, Q2 being positive will repel Q in this direction. Call it F2. What is F1? Force of repulsion on Q coming from Q1. What is F2? force of repulsion coming from Q2. You can see that their directions are opposite. If F1 is equal to F2, if both forces are of same magnitude, then F total will become 0. If F1 is equal to F2, they are of same magnitude, then only F total can be 0. A situation like this will never give you total force 0. If you understand this much analysis, that why we should place our charge on the line joining Q1 and Q2, not at some other position. If you understand this analysis, then write down yes in the comment box. Note down this and then we'll solve the question. Note down this much. Now, the whole thing is only a single equation which you must handle in this form. Look here. This is Q1, this is Q2. Say nine Coulomb. Four Coulombs. This is the position of Q. Let's say this Q is at a distance of X. From 9, this distance is X. If this distance is X, then automatically this distance becomes 16 minus X. 16 minus X. Total distance between Q1 and Q2, that was given 16 meters. So if this much is X, then what is the remaining distance? 16 minus X. And question says we need to find what? X. So far we have done what? This 9 is going to repel Q in this direction with magnitude F1. This 4 is going to repel Q in this direction with magnitude F2. This F1 is what? What is this F1? Between 9 and Q. Between 9 and Q, what is the force? K times 9 into Q upon X square. K times 9 into Q, Q1 into Q2 upon X square. This and this, which is equal to what? F2. What is F2? F2 is force of plus 4 on Q. 4 and Q. What is the separation? 16 minus X. What is this? K times 4 into Q upon 16 minus X square. They both should be of same magnitude. K, K, Q, Q. Everything is gone. Now, what mostly people do, they open these squares. When you open the squares, it makes calculation a bit complicated. Once you cancel K, once you cancel Q, take the square root of LHS and RHS. When you take square root, 9 x square, 4, 16 minus x. You don't have to open the square. If you will open the square, you will get a quadratic equation. Unnecessarily, you will increase the difficulty. We have simply taken root on both sides. Cross multiply. 3 into 16, 48. Minus 3x. 2x. Which is coming 5x 48, or x is coming 48 upon 5 meters. What is the answer? Third charge should be placed between Q1 and Q2 at a distance of 48 by 5 meters from Q1. Look, that's how you should answer. Third charge should be placed between Q1 and Q2 at a distance of 48 by 5 meters from Q1. It gives you exact location of the third charge. Put on this. Now just tell me this thing. If I replace Q from a positive, if I make it a negative charge. In this setup, I have taken my Q as what? Positive charge. If I make Q a negative charge, this Q, these two are still same. If I make this Q negative, then do I get same answer or it will be a different answer? If I replace Q with a negative charge, then do I get the same answer or a different answer? What is your opinion? If you think I will get the same answer, then write down same. If you think that answer will become different, then write down different in the comment box. If I replace Q with a negative charge, then what will happen? Will I get the same answer or will it be a different answer? Think about it. Look, your answer will remain same. Why? But the moment you make Q negative, look here. The moment you make Q negative, what is going to happen? This is 9, this is 4. If your third charge Q is negative, if your third charge Q is negative, what is going to happen? This 9 is going to attract Q towards itself with F1. What is the force of 9 on Q? F1. In the initial setup, we had taken Q positive, force of repulsion, but now Q is negative and therefore positive charge is attracting the negative charge. This is being pulled in this direction. Now, this 4 is positive. This is negative. So 4 is going to pull Q towards itself. Force of 4 on Q was called F2. You have changed the direction. Once you make it negative, their directions are opposite to what they were in the initial setup. This F1 becomes this F1. This F2 becomes this F2. But if their magnitudes are equal, they will again cancel each other and therefore net force still will be 0. And if F1 and F2 are equal, same calculation, therefore same answer. Again, in just one line, let me explain the whole thing. If you say that this F1 is 5, then this F2 is also 5. 5 is cancelling this 5. Over here you are saying that this is 5, this is 5. What is the difference? Nothing. 5 is always going to cancel 5. You have just changed direction of this 5. But they again are what? 5 and 5. And therefore, even in this situation, your F total will be 0. And there will be no change in your final answer. This is something which helps us for some part which is called electric field, and we'll see these type of thing in next classes. Note down this much, write down the answer for the question that when you change Q from positive to negative, nothing changes. This position still remains what? Same. Note down this much and then you can leave. Thank you very much. Yes, you can ask your doubts and So Vritik, you can send your doubts over WhatsApp and I will answer them. Okay? Okay.